Hello everyone. Today I'm going to share about practice problem regarding to the rectilinear by using optimizations, Minisum location problems. So basically, when we want to solve the Minisum location problem, you have to draw. You have to draw first, so it will help you illustrate the situations within the case. So let's say I have five retail shop, and I want to build a depot, a warehouse that will serve all my retailers. So in facility planning, placing a location should be considered many aspects. So we cannot place as we wish because there is a rule to be followed. For example, the availability of resources, material, customer, and everything that will be related in designing locations of a facility. So in this case, I want to place a warehouse that will serve my retailers, about 5 retailers. So each retailer has specific coordinates P1, P2, P3, 4, and 5. And also, each of them has the weight. So the weight represents the importance factor, just like the unit load, material that will be travel to my new warehouse, and each of them has different weight. Now, if we use rectilinear Minisum location problems, so it will be a very rigid tile to be placed because in rectilinear, you have to follow some kind of rule, just like using a specific formula. So now let's solve for the x first because we want to place basically refer to the coordinates, the specific coordinates. So the first thing you have to do, you just find out the x first, the x coordinates for my new warehouse. And then, okay, so before we find out the exact coordinate for my x and y letter, so just do an additions with all the weights. So just sum up all the weight, and then we got 100. So this is the importance weight of my calculation letter. So the total of weights is 100. And now let's create a table and fill with information just like the machines, coordinate, weight, sigma, and also this is a decision statement that every weight should cover at least a half of the total weight. So this is the statements, the iteration statement. Then if the iteration will be stopped if the statement follow the the total weight, which is half of the total weight. Now for an x, let's do by by drawing a line. So drawing a line helps you to figure out the coordinate that will be met firstly, especially for an x coordinate. So let's say you are in the left, so your eye will be left in my coordinates, and draw a straight line. And as you view in this coordinate, you can see that every retailers has different length, has different distance. So according to the closest one to your view, that will be P1 as the first retailer you'll be met, and followed by P3, P4, P2, and the last P5. And just fill the information of each retailers to our table. Okay. So first, P1, or we can say machine 1. So in these problems, we can assume that machines is just like a retailer. So placing a facility, but in my case, I will say it a retailer, so you can easily figure out the actual problems. So let's say this is the first retailer, and then the coordinate is 1. Just fill an x first, which is 1, the x coordinate, and then put its weight, which is 10, and do a sigma for weight. Since it is the beginning, so we can put directly its weight, which is 10, and then does 10 reach at least a half of the total weight? No, so we can go through the second iterations until it reach at least a half of the total weight. And then we see P3 as the second iterations, and the coordinate is 2, the weight is 25, and do a cumulative total weight, So we just sum up the total weight. So just add 10 by 25 equals to 35, and its weight still doesn't reach the minimum total weight, which is 50. So we can go through the third iterations. So the third iteration, so the third retailer that I'll be met after P3 is P4. So put the P4 coordinate and do the same action at the latest iterations, and do a cumulative calculations, and then we got 55. So the 55 in the third iteration reach at least half of the total weight. So actually we can stop in these iterations. So if you're still curious to calculate until all the retailers are already identified, so you can go through that. But actually, if the iteration reach the ending statements, so we can stop the iteration. And then we got an x coordinate, which is 3. So my new warehouse will be placed around the coordinate, which is 3. But for y-axis, still not identified. So we can go through another calculation, finding the right coordinate for y-axis. So let's do the same step for y-axis. So for the y-axis, the first thing you have to do is just draw maybe a line, a straight line. It helps you to visualize the retailer that will be met in your point of view. So this is you. Let's say this is your eyes. If your eyes located in this under the line, so the first retailer you will met is P1, and followed by P2, P5, P4 and P2. Just do in order based on the distance, according to your view. So this is your eyes. So just do the same action, just do the same step as finding an x-axis. So P1 will be put at the beginning, and then the coordinate for a y is 1. Just fill in the box. And the weight for P1 is 10. The sigma weight is 10 since it is the beginning, so we can omit the cumulative calculations, and the ending statement or the closing statement for the iteration is just like the same after at least they reach the half of the total weight, which is 50. So the first iterations still not cover the ending, so we can go through the second iterations. The second iterations will be P2. So P2, just put the same step, fill the coordinate, weight, and the cumulative one. 10 plus 20. And still 30 is not enough to cover the ending statement. And then still go through the third iteration. And the third iteration will be filled by P5. Okay, P5. And just following the same step, do the calculations, and yes, in the third iteration, I reach the minimum ending statement, which is reaching at least half of the total weight. So we can finish in the third iterations. But yeah, if you're still curious in doing the calculation, you can go through the last facility or the last retailer, which is P3. So I have 3 and 4. I have 3 and 4. 3.4. It means that I will locate my new depot or warehouse around that coordinate. So by using rectilinear Minisum location problems, the distance will be totally different because it will follow maybe an angle and line. For example, if I want to reach, if P1, my first retailer want to reach to the depot X, maybe they should follow an orthogonal way here and here. And if my second retailer want to go to new warehouse, maybe they will do an angle traveling, for example. So it's just like a perpendicular or orthogonal line. So that's the characteristic of rectilinear method. Now we can go through the last calculation, which is finding the total weight of my new depot. So by using a rectilinear method, rectilinear formula, you can do a calculations, which is we have a new coordinate for the depot, and then do the calculation within all current retailer. Okay. First, for my P1, so just classify an X first and Y. So 3, just do some subtraction between 3 and its X coordinate, which is 1. 3 minus 1, the absolute number of subtraction within 3 and 1, and add with 4 minus 1. So 1 in here belongs to Y coordinate of P1s. And then don't forget to times it by 10, since 10 is the weight for P1. So just do the sum calculation for P2, P3, P4, and P5. Yeah, okay. For example, 20 is the weight for P2, and then do calculation for rectilinear method. I got 3 as a new current, as a new coordinate, and minus 4 and minus 6, which is belongs to P2 coordinate for an x. Okay, just do the same action, just do the calculation until all the retailers already identified. And then we got 440. So 440 is the weight of my new depot or new warehouse. It should so my warehouse should serve all my retailers, so that all my new retailers can its inventory can be fulfilled enough that consider the traveling distance.